we are here to see how we can bring more systematic approach to our trading, right? So instead of saying, okay, next time when Tesla rises, I will buy it, rather than creating such kind of a mental framework just by looking at a small period of data, what we can do is we can incorporate a machine learning approach or a systematic approach to trading. By machine learning, uh, for those who want a perfect definition, so this is a definition which I have taken from Wikipedia. So essentially, what it tries to say is it's a machine or a computer with some kind of an intelligence. So if you pass the historical data to this machine, it would try to identify the patterns, or it would try to identify the signals where you should have bought or where you should have shorted the stock, and leave it up to the machine to figure out the patterns, right? So for example, I just showed you the example of two stocks, which is Yes Bank and Tesla. But these are just two stocks. But if you all want to trade in say 10 stocks or even 100 stocks, it is very difficult for you to comprehend the patterns, understand which technical indicators work on a particular stock, and so on and so forth. So it's very difficult to devise a very tailored strategy for each and every stock and each and every instrument which are present in this financial markets, right? So to uncover that pattern, what we can do is we can pass all the data which is available to the machine learning algorithm. Let the machine learning algorithm figure out the pattern, the right levels to buy and sell a stock, and we just rely on that. Definitely, based on the performance of the algo, we just rely on that and make our trading decisions, right? So let me explain you through a flow diagram, right? So we have a machine learning algorithm. Let's say this is a machine learning algorithm with all the smartness, all the intelligence, artificial intelligence, which is there. And first, we have to, for us as a trainer or as a programmer, we have to decide what is the outcome which we want from this machine learning algorithm, right? So a typical outcome is, okay, machine learning algorithm, tell me when to buy a stock, right? So in case of Tesla, this will give me the points where I should buy the Tesla stock, right? And not only that, also tell me when should I exit a particular position. Okay, so that is when to sell the stocks, right? So these are very simplistic outcome which we can define from this machine learning algorithm. It can be very complex in the sense I can also ask what will the price of Tesla stock after a month or on a specific date. I can have a more divisions, more bifurcation, right? How when to buy 10 quantities, when to increase my quantities to 20, 30, so on and so forth, and when to reduce my quantities, right? So the levels of classification, this is typically known as classification. So we are having a binary classification, which is binary stands for two. So buy stands for two. So binary classification is in this case is buy and sell. So we can also have multi-class classification. So multi means many. So you can have many levels of not only telling us when to buy, but also telling us how much quantity of the particular stock we should buy, right? But for simplicity, let us restrict ourselves to only binary classification right now. And now comes what should be there on the left hand side of the machine learning, or what should we feed to the machine learning algorithm. So typically we should feed to the machine learning algorithm whatever we think are important for the algorithm or for the machine to make the right decision of when to buy and when to sell, right? So typically what I have observed is most of them use prices, right? Historical prices. They have this mindset of historical prices and some kind of a levels, right? So if Nifty is at 12,000 and if it crosses that, then they think, okay, now they have made a sufficient breakout or something, right? So one thing is we can pass the historical prices. Other is we can pass the technical indicators, right? We can pass RSI, we can pass moving averages, we can pass any technical indicators or any candlestick patterns which you have in mind, right? Someone will look at the shooting star or so on and so forth. Whatever you think can be useful for the machine to make the right choices of trading decisions of buy to sell should be passed to the machine learning algorithms. And for those who are very much into this markets, can also play around with the fundamental data such as revenue, earnings, sentiment data, what people are saying on Twitter, and so on and so forth. Combine all this, pass to the machine learning algorithm and let machine learning algorithm find out the pattern that, for example, whenever RSI is greater than 70, that is when you should buy. Let the machine learning algo figure that out, and we should listen to machine learning algorithm if based on the accuracy, right? So, so very simple example, we should not blindly trust anything, right? So we'll first evaluate the accuracy of the machine learning algorithm. So that is typically we'll observe the performance of the machine learning algorithm on an unseen data or the data which algo has not seen. And in that particular data, if the machine learning algorithm is right, say 80% of time, for example, 80% of time, if machine learning algorithm says buy and next day the price indeed goes up, then that is a trustworthy algorithm. I can trust my hard-earned money with such an algorithm. And next time, whenever the machine learning algorithm will say buy, I will go ahead and buy in the stock markets, either manually or through algorithmic route. It is through automated trading. Right? So that's what we'll be saying now. Any questions so far? Can time be one of the features in fundamental data? So, Ritesh, I think that's a very good question. So, in fact, as a matter of fact, we also use time as a feature for machine learning algorithm because we have seen in the markets like there are a lot of calendar anomalies, right? So, if you just Google and search for some research papers, you will find this very famous research papers on calendar anomalies, which is sell in May and go away, which is essentially saying the market actually typically falls after the month of the May. So, it is prudent to sell your holdings in the month of May. There is this Christmas effects, there is holiday effects, there is January effects. So there are a lot of well-known effects which are well documented, well researched, and some of them still exist in the market, right? So you can also pass the time as a feature to the machine learning algorithm. Right. So there is also another interesting question. So with the shortage of time, I'll be just picking and choosing some of the questions, and for other questions I think they will be answered personally to you either during the session or after this session, right? So when I said 80% of accuracy, right, so that essentially means whenever I said whenever the machine learning algorithm says buy and the stock price goes up next day, if that happens 80% of the times, out of 80 times out of 100 times, then that is the accuracy, right? That does not mean how much profit I'm making per trade, right? So it can very well happen that in the remaining 20%, I just lose say 50%, which is much more than the profit which I have made individually in each of the 80 trades which I have taken, right? So we'll also look at that in this session of how to actually compute the strategy returns, which is the profit factor, which is the profit per trade. Okay, and for rest of the questions, just hold on. We'll have a Q&A to discuss in detail, but let me quickly check if anything is specific to this concept. I'll just definitely answer it right now. Okay, I just quickly went through. So there are a lot of questions on the what kind of data which we can use through, right? So typically, the choice of the data is completely up to you, but I'll just give you some key thought process of what kind of data you can pass through. You can pass through all the data which you think has some kind of a predictive power to forecast the future price movements, right? So if you're trading in Tesla and you know Elon Musk is active on Twitter and that does have an impact on the Tesla stock prices, right? So in that case, you can include the sentiments data, corporate news data, and all other stuff to forecast more accurately the Tesla stock price, right? And that might not be true for a small cap stock in an India, which does not have any kind of a media presence, which promoters does not have any kind of a social media presence, right? So you will hardly find any mention of such companies in the social media. So in such cases, passing a sentiment data to your machine learning algorithm will not be any helpful, right? So always keep this in mind. All the data which makes sense for machine learning to more accurately forecast the future price movements should be passed to the machine learning algorithm. Okay, and let's take an example so that I think you'll have more clarity. So I'll be referring to the example which you can see on my screen. So the link of the notebook is on my screen. So it's one of the course on Quantra. And Kinnari, if you can also post this link in the chat box to everyone, I think it will be very helpful. They can also follow me along with coding.
Yes, of course. I'll just do that right now.
Okay. So that particular link will take you to this page. So I'll wait for a minute so that you can open this on your own end. Okay. So let us start. Um, so now we'll approach this machine learning from left to right. So first, what we'll do is we'll define the features, right? What should be the features for this machine learning algorithm? This is a very simplistic example which I am taking, but please feel free after this webinar is over to actually enhance and enrich this features as you deem fit, right? So very first step in actually designing and creating any algorithm is importing the libraries which you'll be working with. If you're not aware like which are libraries will be required, you can also import on need basis, right? But some of the libraries which are often used are NumPy, Pandas for data manipulation, data reading, Matplotlib for plotting and visualization, and sklearn is very popular in Python for importing machine learning specific libraries, right? Either it can be algorithms or it can be for computing the matrices. So let me import this libraries. You can run this cell by pressing Shift plus Enter. So it will run the cell and take you to the next cell. Then we already will be working on predicting or forecasting the S&P 500 directions, whether to buy or not to buy or to sell. So the data is available here in a CSV file. So we are reading that. Now comes the most interesting part, which is defining the features. So here, for illustration purpose, what we are taken is the difference of open and close and high and low as two features which will go inside this model, machine learning model for now. So as you can see, these two features are defined and you can see on the screen. And the next step is to define the output. So here it is the output is buy and sell, but there are a lot of long only investors. So what I've done is I've defined if the close price for the next day, which is close dot shift of -1. So whenever I say shift of -1, it goes to the next cell. So whenever the close of the next day is greater than the close of the current day, as you can see the greater than sign, what I've done is I've set the signal to 1. 1 typically indicates buy and 0 indicates no position, right? You can modify this to 1 and -1 to indicate buy and sell, buy or sell. So this is how I have defined the target variable or what is the expectation from the machine learning algorithm, right? So as discussed, this is a binary classification which we'll be working with. Okay. Now what we'll do is we'll split the data, right? So remember I told you want to trust your hard-earned money on this machine learning algorithm. So you just cannot give it as it is. So what you'll do is you'll essentially divide the data into two parts. One part of data you'll allow the machine learning to figure out the patterns to learn when to buy and when to sell. And when it's ready with the learning part, the second part you'll use to check the accuracy of the algorithm, right? How well are you performing on the data which is not seen to you, right? So very layman explanation of this is the training set can be considered as the classroom where teacher is coming and teaching. So in this, the machine learning algorithm is figuring out on himself of if I do this, what is the outcome? And once that training phase is over, he is put into some kind of a live projects like not told like he's put on a job and he's using his knowledge which he has learned in the classroom to make the predictions and will be judging whether those predictions are right or wrong, right? So those are the two data sets which are here. So essentially we'll call the fit method. Fit is basically where the machine learning will figure out the patterns on a training data set. That's why you can see the train uh, suffix after the word x and y. X are my features, y is the output variables. So x is the features, which is this yellow box, and y is this green and the red box. So so CLS is the machine learning algorithm, right? So this blue box, which you can see, is the CLS, which is the classification, stands for that. I am using SVC, which is support vector classifier. There are tons of algorithm. We'll not be going into discussion of which algorithms are good and which are bad, but you'll find the link for top 10 machine learning algorithms in these slides later on. But now, for now, let's say there is some X algorithm, uh, X machine learning algorithm, which is used, which is currently learning from the training data set, and that whatever he has learned, whatever the machine learning algorithm has learned, is stored in the CLS variable. Okay. Now comes the interesting part, which is we'll say CLS, which is machine learning algorithm. Whatever you are done is on the training data set. Now, why don't you do the same thing on a testing data set, which is the unseen data set, which you haven't seen right now? Tell me what should I do, whether I should buy or don't buy, and I will actually compare with the actually what has happened during that period of time, right? So that is my Y test. So Y test is actually if the stock price has gone up, then it will say buy. And CLS.predict is basically what is machine learning telling me. If machine learning also tells me buy, then that is a perfect hit. Machine learning is accurate about that particular day. If actually it was buy and machine learning is telling sell, so machine learning was wrong on that day, and that is a miss on the machine learning part, right? So as you can see on my screen, the accuracy numbers are for train it is 86%. So when the data is available, that is 86%. But on the unseen data, machine learning algorithm is right 64% of time, right? And someone has rightly pointed out, being right does not mean that you are profitable, because some few small, large negative trades can wipe out your portfolio, right? So now let us see if we follow this guidance of machine learning algorithm and trade according to that, how would have my strategy perform, right? So what I'll do is I'll store whatever the machine learning algorithm is telling me in the predicted signal, and I'll compute the return. So return is nothing but the change of the price from today to tomorrow. If today is 100, tomorrow is 102. So the percentage change for me is 2%. And strategy returns is simply the return, which is 2% into what has machine learning algorithm told me. If it is buy, which is 1, I'll simply multiply by the 2%, and that is my gain. If machine learning algorithm is saying don't do anything, then in that case it is 0. So 0 into 2 will be 0. So that is how my strategy returns are. And as you can see on my screen, on the unseen data, this is how my strategy would have performed. So it would have performed giving me approximately 33% returns during this time, right? Now, this is just a sample strategy. This should not be used as it is, right? So, few things which you can work in the strategies, defining more features so that machine learning algorithm is more accurately able to understand the patterns, right? So one of the things which I can do is introduce a technical indicator. So one of the very famous technical indicator which is widely used is RSI, right? So I'll compute the RSI over the closing price for a period of last 14 days, and also add RSI to this bucket. Okay, so now RSI is part of the features. Rest of the things remain as it is. And what I will do is I'll first train the machine learning algorithm and then see how the performance goes, right? So by adding RSI to the feature list, what is happening is the train accuracy is increasing beyond exceptions, right? 99%, which is very close to 100%. Maximum you can get is 100%, right? Which is right each and every time, right? But the test accuracy has reduced. So this is an important thing which I like to highlight to everyone, and which is one of the most missed aspect of this whole process is overfitting, right? So the machine learning overlearned in the training data set, and when unseen data came, it was actually failed miserably. So previously it was 64%, and now it has gone down to 60%, right? So this is you can think machine learning algorithm is not able to adjust or correctly decipher the nuances or pattern in the financial market data, right? So this is a short recipe of disaster, and overfitting should definitely be avoided, right? So you can play around with this. I am not going in very detail of how to add features and remove features, but this is a playground for you as a quant analyst, quant researcher, for you to devise, think about features which can add value to your machine learning algorithm, add them and see whether they are effective in any adding incremental alpha to your strategy or not, right? So let's say you went through this whole process, and now you are very satisfied with the performance of this strategy, right? Now you think, okay, this machine learning algorithm is worthy of my money, right? So what you'll do is you will continue your journey in the Contra course. So in the Contra course, you learned about the strategy. You'll continue your journey. You'll learn about different things. And what we have is for you is a ready-made template. So whatever you have learned in terms of strategy, you can just click here, and this will open a new window for you. And this window is essentially giving you a template for you to connect to the broker and live trade your strategy. So by live trade typically means that you can simply connect the strategy to your broker. So whenever the signals are generated like a buy, an automated order is generated, which is buy order, and it is placed with your broker. So there is no manual intervention. That is the right way to think about it. In Indian markets, it's actually there is a not clear-cut regulation of how you can do that. So there is also one-click execution facility which is available here. So whenever the algorithm will generate a buy signal, you get a notification that the algorithm has generated a buy order. You simply click a single button and the buy order gets placed. But in the foreign markets like US, Europe, there is no such restrictions. So you can completely automate the order placements also, right? So as you have noticed, like whenever I click this button, this is one of the unit within the course. Whenever I click on this button, a new window opens up, and this is the same strategy which we have seen right now, but in a slightly event-driven format. So let me quickly explain you what things have changed. So we are using zipline here. So there are new methods which are coming, which is the order method and schedule method. So order method, as the name says, will enable you to place order to your broker, and schedule method will enable you when to call the logic method, right? There are various securities which are available. So FB stands for is the ticker for Facebook. If you want, you can change to say Amazon, and that should be fine. It will fetch the data for Amazon, and you can play with that. These are various parameters, same as what we have seen in the notebook. And this data.history is used to fetch the data. In the notebook, what we have done is we have used the CSV file, but in this, you can get the data in a real-time basis. These are the same features which we have computed, which is open and close and high minus low. If you think you have changed some features, for example, let's say I changed and normalize this feature. So let's say divide by close, then you can also do here whatever changes which you have done in the notebook while finalizing the algorithm. Similar changes you can also do here. So let's say I'm normalizing my features, like that is not only taking the difference but also dividing by the close and normalizing the features. So that you can do here. And this is the same thing. We are calling the SVC method and fit to it, and creating this algorithm and computing the accuracy. And if the accuracy is greater than 50%, which indicates that there is not fluke, there is some kind of understanding which machine learning has developed over a period of time. If that is true, then only whatever the machine learning algorithm is telling me, if it is telling me that it is one in sense it is buy, then what I'll do is I'll place the order with the broker through this method. So this method takes which instrument I want to buy or sell, and one indicates that 100% of my portfolio should be allocated to this particular security. Don't worry if you are not able to understand this methods, like what is this and so on and so forth. You can refer to the section before this, which is live trading on blue shift, and each and every method is discussed in detail. But for now, for understanding, this is a method which will place order for that particular security whenever my machine learning algorithm will tell me buy. This is the automated execution piece. So if you just use a notebook, it will tell you buy. You manually have to open your broker account and place the buy order. But by using this, all the execution will be seamless. It will be in a automated fashion, right? And since we have changed the asset, you might want to check out how the performance would have been. So what you can do is you can select the data set. Let's say I select NYSE minute. You can select the start date. So going back too much is not helpful. So let's say start from 2017 and up to 11th Jan 2021, which is up to yesterday. Right? So by clicking on run, it will initiate a backtest, and we can see the performance from 2017 to now on. And this matrices are updated as and when the backtest is progressing. So as you can see, it's generating a return of say 40-50%. And I think more than returns, I think it is important to look at the Sharpe ratio, because anyone can increase the returns by increasing the leverage, but that person cannot increase the Sharpe ratio. So Sharpe ratio becomes the key matrices to evaluate. And also note the algorithm is not trading, which you are seeing are flat lines. And this is due to the fact that we have imposed the condition that the accuracy has to be greater than 50%. So if that is not the case, we will not be trading in the market. And that's why you are seeing this flat lines, right? So once you think, okay, this is decent enough, a Sharpe ratio of 0.8. By the way, that's not decent enough, but let's assume that we got a good Sharpe ratio by you worked on this algorithm, put in a lot of efforts, and created a very good strategy. And let's say you got a decent Sharpe ratio. Now there is a time where you can take it live. You just click on here, which is go live,